A very good morning, friends. Today we'll continue lecture number 9 on permutation and combination. Basically, this lecture is based on circular permutation. So let us start lecture number 9 on circular permutation. N factorial divided by n is equal to n into n minus 1 factorial. Will give you n minus 1 factorial ways. This is first very important thing. Whenever it is in line, row, it is npn, n factorial ways. But whenever it is on circle, it is n minus 1 factorial ways. Second point is what? Out of n objects, any r objects on circular table can be arranged in number 1, when clockwise and anti-clockwise arrangements are distinct in NPR divided by R ways. And second one is what? When clockwise and anti-clockwise arrangements are not distinct. Not distinct means same. जैसे कि माला में clockwise और anti-clockwise arrangements are same, are not distinct, that is same in NPR divided by 2R ways. The next point is out of n objects, a particular object repeats n times on circular table can be arranged in n minus 1 factorial upon n factorial ways. So let us start problem based on this. In how many different ways can 8 friends sit around a table? 8 friends on a circular table can be arranged in 8 minus 1 factorial 7 factor is equal to 5040 ways. A party has 20 participants. Find the number of distinct ways for the host to sit with them around a circular table. Total number of persons 20 guests plus 1 host is equal to 21. 21 persons on round table can be arranged in 21 minus 1 factorial is equal to 20 factorial ways. This is first part. Then they are asking how many of these ways had 2 specified persons on either side of the host. Since 2 specified persons are always on either side of host. Therefore, the 2 specified persons along with host we will take as one group. Therefore, one group plus 18 other guests is equal to 19 on round table can be arranged 19 minus 1 factorial is equal to 18 factorial ways. The 2 specified guests who are on either side of host among themselves can be arranged 2p2 2 factorial two ways. Therefore, total number of arrangements will be what? 2 into 18 factorial ways. So this is answer of second part. Delegates from 24 countries participate in a roundtable discussion. Find the number of sitting arrangements where two specified delegates are always together, never together. Since two delegates, two specified delegates, delegates are always together. Therefore, we will take them in one group. Therefore, one group plus 22 out of 24, two are in one group, plus 22 other delegates. Is equal to 23. On a round table, can be arranged in 23 minus 1 factorial is equal to 22 factorial ways. The two the two specified delegates who are in group among themselves can be arranged in 2p2. 2 factor is equal to 2 ways. Therefore, total number of arrangements 2 into 22 factorial ways. Second case is what? Two delegates are never together. B part. Two specified delegates are whenever the word two specified is not mentioned, then in that case, the two delegates can be any. So out of 24 delegates, first we to select any two delegates. But here they mentioned specified. So particular delegates. So we are doing this way. Two specified delegates are never together. So restrictions is put on the two delegates. So first we will arrange remaining 22 delegates. So remaining 22 delegates on a round table can be arranged in 22 minus 1 factorial is equal to 21 factorial ways. Now see, whenever we have to arrange the two delegates in a row, then in a row you'll observe 23 places, meaning 22 plus 1, 23 places for the two particular delegates or two specified delegates where they are not together. But when you are arranging on circle, then it will be same number of places, neither more nor less. It will be exactly 22 places. If you want, you can see here, if only 5 delegates are there, on which there is no restriction. So these are 5 places for them on circle. 3, 5. And for two delegates, there will be 1, 2, 3, 4, 5 places only. No more, no less. Exactly 5. If 22 persons are there, there will be 22 possible places. So this is what you remember. In circular way, it is what same number. For two specified delegates, there will be 22 possible places on a round table where they are never together. They can be arranged in 22 P2 is equal to 22 factorial upon 20 factorial. 22 minus 2 is what? 20 factorial. Which is what? 22 into 21 into 20 factorial upon 22 into 21 ways. Therefore, total number of arrangements will be what? 22 into 21 into 21 factorial. Will be what? 21 into. Now we'll take 22 and 21 factorial together. Is equal to 21 into 22 factorial ways. So next example. Find the number of ways for 15 people to sit around the table so that no two arrangements have same neighbors. 15 tables on a round table can be arranged in so that no two arrangements have same neighbor. In 15 minus 1 factorial divided by 2, 14 factorial divided by 2 ways. A committee of 10 members sits around the table. Find the number of arrangements that have the president and vice president together. Since we are arranging president and vice president together, therefore we will take them in one group. Therefore, one group plus eight other members is equal to 9 on round table can be arranged in 9 minus 1 factorial is equal to 8 factorial ways. Now, president and vice president who are in a group among themselves can be arranged in 2p2, 2 factorial is equal to 2 ways. Therefore, total number of arrangements is equal to 2 into 8 factorial, 2 into 40,320, 80,640 ways. Five men, two men, and a child sit around the table. Five men, two men, and one child. First possibility is what? Child is between two women. Child between two men. We will take as one group. Therefore, one group plus 5 men is equal to 6. On round table, can be arranged in 6 minus 1 factorial is equal to 5 factorial, 120 ways. Now the two men, Sita, Geeta, and the child. Now the two men among themselves can be arranged. 2p2. Only the two men, not along with child. Because child should be in center only. The two men among themselves can be arranged in 2p2 2 factorial is equal to 2 ways. Therefore, total number of arrangements is equal to 2 into 120 is equal to 240 ways. Two into 120 is equal to 240 ways. The next part is what? Between two men. B part. The child is between two men. First, now this is not two specific men. They can be any two. So first we have to select two men out of 5 men. First of all, we will select two men out of 5 men. They will be M1, M2, M1, M3, M1, M4, M1, M5, M2, M3, M2, M4, M2, M5, M3, M4, M3, M5, M4, M5. That is 10 ways. If we take out of 10 ways, if we take any one, M1, M2 say, child should be between them. We'll take as one group just like this. We can arrange in 240 ways. And like this, there are 10 selections of 2 men. So 10 times 240 will give you what? 2400 total arrangements will be there. So let me write. If the 2 men are M1 and M2, child between they will take as one group as in case 1. That is this case. As in case A, as in case A, we can arrange in 240 ways. Like this, there are 10 selections of 2 men. Therefore, in one selection, 240 arrangements are there. In 10 selections, it will be 10 times 240. Therefore, total number of arrangements will be 10 times 240 is going to 2,400 ways. Eight men and 6 women sit around a table. How many of sitting arrangements will have no two women together? So restriction is on women. So first we'll arrange men. 8 men on round table can be arranged in 8 minus 1 factorial 7 factorial equal to 5040 ways. For 6 women, there will be 8 possible places on round table where no two women are together. Therefore, 6 women at 8 different places on a round table can be arranged in 8p6. 8 factor upon 8 minus 6 is or 2 factorial is equal to 40,320 upon 2, 20,160 ways. Therefore, arrangements is equal to 5040 into 20,160 is equal to 5040 into 20160. 10160 6488. Find the number of sitting arrangements for 3 men and 3 women to sit around a table that exactly 2 men are together. Three men and 3 women. Exactly 2 men sit together. Out of 3 women, 2 women can be selected in this is selection. So 3C2, which is 3 ways. We will take selected 2 men in one group. Therefore, one group plus now 3 men plus 1 woman is left plus 4 other persons is equal to 5 on a round table. Can be arranged in 5 minus 1 factorial is equal to 4 factorial 24 ways. The 2 women who are in group among themselves can be arranged in 2p2, 2 factors equal to 2 ways. Therefore, total arrangements will be will be 2 into 24, 48. This is one selection of 2 women. Like this, there are total 3 ways in which we are selecting 2 women. Hence, total number of arrangements of 3 selections of 2 women is equal to 3 times 48. 144 ways. 4 objects in a set of 10 objects are alive. Find the number of ways arranging them in a circular order. Out of 10 objects, 4 objects are alive. Therefore, they can be arranged on circular table in 10 minus 1 factorial divided by 4 factorial is equal to 9 factor upon 4 factorial. 9 into 8 into 7 factor upon 24. 9 into 72. 72 upon 24 is what? 3 into 5040. 15,120 ways. ये कौन सा है? 10 तो हो गया ना, 11 है क्या? 15 persons sit around a table. Find the number of arrangements that have two specified persons not sitting side by side. This is 11th one. Two specified persons are not sitting side by side. The remaining 13 persons on round table can be arranged in (13 minus 1 factorial is equal to 12 factorial ways. For two specified persons, there will be 13 possible places. On round table where they are never together. Therefore, they can be arranged in 13p2 is equal to 13 factor upon 11 factorial is equal to 13 into 12 into 11 factor upon 12 is. Therefore, total number of arrangements is equal to 13 into 12 into 12 factorial. I'll take 13 and 12 factorial together. So 12 into 13 into 12 factorial. And this will give it 12 into 13 factorial ways. Thank you so much. Today's quote is, जिंदगी कभी एक मिनट में नहीं बदलती, लेकिन एक मिनट में लिया हुआ फैसला पूरी जिंदगी को बदल देता है। कितनी बड़ी सोच है, ध्यान रखिएगा। थैंक यू।